Hi Jude, the event that I'll be talking about for this video took place in week 2, where we were focusing on multiplicative thinking. So after running through the strategies for 0 to 9 for multiplication, I was paired with student B to play multiplication toss. The student was confused with recording the region, and she kept recording with a focus on the number in each group as opposed to the number of groups. So for example, if she rolled a 3 and a 4, she would record it as 4 3s rather than 3 4s. So the misconception here is that she has insufficient mental strategies to support multiplicative thinking and is relying on a groups of understanding for multiplication. So as a consequence, this student tends to rely on memorized procedures for multiplying and dividing larger whole numbers and decimals. Another example of this from the same student was in lesson 1, where she referred to the finger trick for the 9 times tables. So the main teaching point to address this misconception is that a shift in thinking is required from a focus on the number in each group to the number of groups. So this will support the multiplication and division of larger whole numbers. It supports multiples and factors, fractions and decimals, and algebra. It's also needed to support more efficient mental strategies for multiplication. An appropriate teaching method to address this would be to build mental strategies for multiplication and division facts. So you start with the 2's facts, which is doing doubles. So if you've got 2 7s, you think double 7 is 14. You go the 3's facts, which is doubles and one more group. So 3 8s, you've got double 8 is 16 and one more 8 is 24. The 4's facts, which is double doubles. So if you've got 4 6s, you think double 6 is 12 and double 12 is 24. The 5 facts, which you relate to 10s. So if you've got 5 8s, you think 5 8s is half of 10 8s, so that's 40. The 9 facts, which is 10 groups less 1 group. So if you've got 9 8s, it's less than 10 8s. So it is 8 less, which is 72. And then you've got the 1's and 0's facts, which you think of them as same as. So 1 1 is 1, or 1 4 is 4, so it's the same as. You then need to deal with the remaining facts. So those are times tables like 6 times 7 or 8 times 8, so the ones that don't have any facts for them. So for those, you just do a combination. So you might do, for 6 7s, you might think 3 7s and 3 7s and get to 42. Or for 8 6s, you might do double double doubles, which will get you to 48. To consolidate this thinking, you'd use multiplication toss, which is the game that we originally got stuck on. So this uses the regions idea to develop more efficient mental strategies for multiplicative thinking. So it encourages a switch in thinking from the number in the group to seeing the number of groups, which is what we're wanting to address here. A key indicator of the extent to which students have developed a broader range of ideas to support multiplicative thinking is the extent to which they can manipulate both the size of the group and the number of groups to meet specific needs. So this might be done through part whole knowledge. So at any time in the game with multiplication toss, a player can decide to partition or split the region. So instead of committing 6 8s to memory and just doing it that way, you might recognize that it can be thought of as 5 8s and one more 8.